Now, we come to the most useful and the most important principle in physics. This is the analogy of the conservation of linear momentum. Here, we will talk about the conservation of the angular momentum. The concept is very similar to the linear momentum case. That is, we know that the torque is equal to the rate of change of the angular momentum. Now, if the torque is equal to 0, so it means that there is no change of the angular momentum, or we can say that the angular momentum is a constant. Okay? Or we can say that in any process that there is no external torque, we will have that the initial angular momentum will equal to the final angular momentum in that process. The important point here is that the torque is the torque of the external force. It means that we can have the internal force in our system, but if there is no external force in our system, we can say that the total angular momentum will not change, or we have the conservation of the angular momentum. In many applications, when we talk about the rotation of the rigid object, we can write, as we have discussed before, that the angular momentum is equal to the product of the moment of inertia and the angular speed. So it means that in the rotation of a rigid object, if there is no external force acting on that object, it means that the angular momentum will conserve, and we can write that the product of the moment of inertia and the angular speed will have the same value, or it's a constant during the process. Anyway, if the distribution of the mass of the object can change, the moment of inertia can change. But if that change comes from the internal force, it will not change the value of the angular momentum. So it means that the product of I and omega will be constant. But if I change, it means that omega will change also. This effect has many applications in sport, or maybe in automobile, or in the spacecraft, and I will add some example in the video clip. Follow this video lecture. To summarize, so far we now have 3 principles of conservation. The first one is the conservation of the energy. Okay? In the system that the force, all forces are conservative force, we must have that the total energy of the system is conserved. So it means that if we add up the kinetic and potential energy, the result will not change in time. Anyway, the kinetic energy may change, the potential energy may change, but if we sum up the change of those 2 energies, it will cancel, and the total energy will not change in time. The second conservation law is the conservation of momentum, of linear momentum. That is, if we have a system of particles and there is no external force, we can say that the total linear momentum will not change in time. So we have the initial linear momentum will equal to the final linear momentum. Okay? So this is the conservation of linear momentum. And the last one is what we have just discussed, that is, if there is no external force, it means that if there is no external torque, that is, if there is no external force that produces the torque. We may have the external force, but if that force does not produce the torque, we can say that there is no external torque. And if there is no external torque, it means that the angular momentum will be constant. So we have constant value of the angular momentum.